Paul flips a coin until he gets heads or tails consecutively. What is the chance that he stops on an even number of flips? Okay, so stopping on an even number of flips can be represented as, and having it consecutively can be represented as 1/2 times 1/2, or 1/2 times 1/2 times 1/2 times 1/2, and I think you get what I'm doing. This is like 1/2 times 1/2 just represents getting consecutively and doing that an even number of times. Yeah, that's what the problem's asking. So you have 2 and 4, and so this can actually be represented as 1/2 to the 2 to the n. So make sure this is always even, so you multiply it an even amount of times, or flip it an even amount of times, and then this can actually be rewritten as 1/4 to the power of n. And this is where infinite sum comes in, because to get the probability of it being even, you have to do all the chances. And so you go from 1 to infinity of 1/4 to the n. And we actually can find what this converges to, because it's of the form, the infinite sum from 1 to infinity of a times r to the n minus 1, and we know this converges to a over 1 minus r. And so in this case, a is equal to 1/4, and r is also equal to 1/4, because this is our first term. If you plug in 1, you just get 1/4, and then when you plug in 2, it's just 1/4 times 1/4, and so that's the common ratio. And then this, so we plug it in, so it's 1/4 over 1 minus 1/4. This is 1/4 over 1/3, 3/4, and then you get 1/3. But we're not done there. This is just for one case of like a tails, because you're just representing one case of this happening. So what you need to do is then just multiply by 2 to get both cases of heads and tails to get 2/3. And that is the answer. So it's pretty awesome.